power and exponent. Say, for example, that a is a real number, okay? Any number that is real, and n is a positive integer. Okay, so 1, 2, 3, 4, 5, and so on, and it's positive integer. So if we have a number like this, represented like this, a to the power of n, what this means is a times a times a times a, and so on. So this is how many times we are multiplying a. We are actually multiplying n times, okay? The power of n means we're multiplying n times. So for example, a to the power of 2 means that a times a. We are multiplying twice, 2 times. A to the power of 5 is a times a times a times a times a. So we are multiplying 5 times, okay? So here, when we have a number like this, okay, this number is read as, okay, it's read as a to the power of n. This is how we read this, a to the power of n. So if we have 5 like this, then we read this 5 to the power of 6. Okay, so this is how we read this. This number here, a, it is known as the base. N here is known as the exponent. Okay, so the number on top is the exponent, and the number bottom is the base. Okay, so how do we read this? A to the power of n. Okay, so far so good?
Yes.
Yes, madam.
Okay, so now let's look at the laws of exponent. Laws of exponents, okay? Okay, let's look at several examples first before we go to the laws, okay? So if I give you a to the power of 2 multiplied by a to the power of 3, this actually means that we have a to the power of 2 means 2 times, a multiplied by a. And then we have a to the power of 3, that means times 3a times a times a. So all together we have a to the power of 5. In other words, how do we get this? A to the power of 2 plus 3. Okay, a2 times a3 is also equals to a to the power of 2 plus 3. Okay, that's the first example. Okay, example 1. Example 2. If we have a to the power of 3 divided by a to the power of 2. This actually means a multiplied by a multiplied by a divided by a to the power of 2 is twice, okay? So a multiplied by a. If you solve this, we get a, which in other words, this also equals to a to the power of 3 minus 2. Okay, that's example 2. Example 3, a to the power of 2. If you cube it, this actually means a squared times a squared times a squared, 3 times cube. So 3 times multiply, okay? And we expand this, we get a squared is a times a times a squared is a times a, okay? A times a times a times a times a. So this gives us a to the power of 6. So how did we get this? A to the power of 2 times the 3. So we got a to the power of 6. 2 times 3. Okay. Okay. So from here, we can generalize the laws of some of the laws of exponent. The first law of exponent is, number 1 is a to the power of m times a to the power of n is equals to a to the power of m plus n. Okay, given that, okay, given that m and are elements of q. What is q? What is q, everybody? What kind of numbers are represented by q? You forgot last semester's paper. rational numbers, so the m and n are rational numbers, and a is the element of real positive numbers. Okay, so the first law is a to the power m times a to the power n is equals to a to the power of m plus n. Okay, from the second example we have a to the power of m divided by a to the power of n will give us a to the power of m minus n. And from the third example we have a to the power of m to the power of n is equals to a m n. Okay, so these are the first three laws of exponents that we must remember. Okay, we're going to use this in our calculations. Okay, so other than this we have a few more laws. Okay, we have a few more laws here that we want to use. Okay, which you already know this one, a to the power of 0. We know that a to the power of 0 is equals to 1. Okay, what is a to the power of negative n? How do we rewrite this?
A divided by N.
A divided by
1 over A.
1 over A.
1 over a to the
Power
power
n.
of
Power of
n.
N.
Okay, so whenever you have negative here, you can rewrite it as 1 over a to the power of n. Okay, so what is a to the power of 1 over n? How do we rewrite this? What is a to the power of half? Anything to the power half is?
Square.
Yes, square root.
Square
Square
root.
root of a. A to the power up is
2.
square root of a. So what is a to the power of 1 over n? Root
Square root A power
a to
to the
n.
power
So
of
we call
N.
this root
Oh,
a root n. A root n. Okay, the n is root is n here. Okay, so here is square because it's 2. So square root here is root n. Okay, and what if we had a to the power of m over n? Then this will be root a. What do we write here?
square root A N.
What do we write m or n here?
N.
N, N.
Outside N.
N.
N. Okay, the bottom number is here. Okay, n. Now we can write this one m here, or it is also the same as square root a root n. Root n, the whole thing to the power of m. You can use either way. You can do either way. They both means the same. Okay, and the last thing that we want to see is a to the, if there's a to the power of x is equals to a to the power of y, then x is equals to y because the base is the same. If the base is the same, then the powers are equal also. Okay, so these are the 8 laws of exponent that we are going to use in our calculations. This is revision for you, and it's quite simple. Okay, you don't have to memorize all this. Okay, okay, let's look at some calculations, some examples. Okay, examples for power and exponents. Okay, example 1. Okay, first we want to find the value of 27 to the power of 2 over 3. Anybody can tell me the value first before I show you how to do it? Anyone got it ready? Okay, this is 27 to the power of 2 over 3. This formula that we're going to use is a to the power of m over n. So we can write this as 27 root
3.
Yes, root 3, the whole thing square. So what is 27 root 3?
9. 3.
3.
Yes, 3, root 3, so 3. So 3 square is equals to 9. Okay, that's question 1. Okay. Question 2. Solve. 16 over 81 to the power of negative 3 over 4. Okay, so how do we do this? What do we do first? This is negative 3 over 4. Okay, so okay, I'm going to show you step by step. Maybe later when you're solving questions like this, you want to skip steps, it's okay. Okay, or later you can, there's a shortcut, we can use that. So for now, we start with, if it's negative, power is negative, then it's 1 over, correct? 1 over 16 over 81 to the power of 3 over 4. What this means is, it is 1 over 16 to the power of 3 over 4 over 81 to the power of 3 over 4, correct? So if it's 1 over 1 divided by 16 over 81, so we have 81 to the power of 4 over 16 to the power of 3 over 4, correct? Is this correct?
Yes.
Yes, sir. So this is equals to 81 root 4 cubed over 16 root 4 cubed. So what do we get here? What is 81 root 4?
Oh.
4 times. What number 4 times will give you 81? 3, right? 3 times 3 times 3 times 3 is 81. So this is 3 to the power of 3 over 16 is 2. Okay, so solve this, we get 27 over 8. Okay, so next time when you're doing, when you see a fraction number here and to the power of negative, you can go straight here. Okay, from here straight away you change it to, you inverse it, 81 over 16 to the power of 3 over 4. Okay, that means this one is also equals to 81 over 16 to the power of 3 over 4. If it's negative, you inverse the number and put it the positive power. Okay, that is how you do that. So question 1 and question 2. Okay, so now we look at question 3. Okay, question 3 is 0.25 to the power of 3 over 2. So how do we do this? This is a decimal number, difficult to work with decimals. So what do we do?
1 over 4.
Correct. So this is 1 over 4 to the power of 3 over 2. So this is 1 to the power of 3 over 2. And this is square root of 4, square root. If it's square root, we don't have to write the 2. But if you write it, so it's not wrong. Okay. So this is 1 over 8. Okay.
Okay.
Okay, question 4. Okay. Find x when 9 to the power of x is equals to 27. Okay, how do we do this? When you look at 9 and you look at 27, you know they are somehow related. So what can we do? Can we write them both in the same form? How can we write this? How?
3 power of 3.
That's for 27, 3 to the power of 3. Okay, correct. Okay, so because the base is the same, we also write 9 to the power of 2. Okay, 3 to the power of 2 is actually 9, like this. Okay, so this is actually 3 to the power of 2x is equals to 3 to the power of 3. Because the base is the same, therefore the power is, the exponent values are also the same. So x is equals to 3 over 2. Okay. Simplify, 32 to the power of 3 over 2 multiplied by 2 to the power of negative 3 over 2. How do we do this? You look at the 32 and 2. Look at the base numbers first and see if they are related. Can we change 32 in the form of 2?
Yes.
What? 2 to the power of?
4.
Again? Check.
2 power of 4.
2 times 2, 4, 4 times 2, 8, 8 times 2, 16.
To the power of 5.
5.
Yes,
5.
to the power of 5. One more. Okay, so this is 5, and then we have 3 over 2 here, times 2 to the power of negative 3 over 2. So this is 2 to the power of 15 over 2
Times
times 2 to the power of negative 3 over 2. So now the base is both the same, and we have multiplication symbol in between. So what do we do?
15
Plus.
over 2 plus
Yes, correct. Plus negative 3 over 2. So we
3
get
over
12 over 2, right? So this is 2 to the power of 6,
6 over.
which is 64. Okay? All you
Okay.
have to do slowly, step by step. No need to rush and skip steps. Okay, let me try one more question. Negative 2 to the power of 3 multiplied by negative 2 to the power of 7 divided by 3 times 4 to the power of 6. Okay, how do you go do this? What is the first step? Can we solve the numerator? What do we get? Base is the same, right? Negative 2, negative 2, and then we have multiplication. So how do we solve the numerator?
It will become
3 plus
negative 2 power of
Power
11.
of
10.
Plus 7.
3 plus
3
7,
plus
correct.
7.
Over, what can we do with the denominator? Can we change anything? The 3, we cannot do anything about it, okay? This one, can we do anything about this?
Yes.
Oh yeah, how? What do we write?
2
The
to
power
the
of
up to
Correct?
plus
Okay,
6.
so we have negative 2 to the power of 10 over 3 times 2 to the power of 12. Okay, now what do we do? We can see this 2 here, we can see the negative 2 and 2, and we know somehow we can solve this. What do we do?
Minus.
Hmm? Okay, I give you one clue. Negative 2 to the power of 2 is how much?
Oh, 4.
2 to the power of 2?
4.
Okay, now what can we do here?
Put the bracket.
Here?
Negative
Can you
10.
put the bracket?
So then what does it become? So does this become negative 2 to the power of 10? Because this is even number, power is even, okay? Negative 2 to the power of 10 is also same as 2 to the power of 10, same value, correct? Negative 2 to the power of 10 is the same as 2 to the power of 10 because power is even. Okay, so negative and negative will become positive. So it's 2 to the power of 10 over 3 times 2 to the power of 12. Now can we solve these two?
Yes.
Yes.
Okay, how do we solve that?
10 minus 12.
Yeah, so it's actually 1 over 3 times 2 to the power of 10 minus 12. So 1 over 3 times 10 minus 12 is 2 to the power of
Negative
negative
2.
2. So this also 1 over 3 times 2 to the power of 2 is 1 over 12. Okay, that's it. Okay, so